Good afternoon, everyone. Let's get started. Today, we're going to talk about stacks. About course logistics. Homework 3 was due today, and homework 4 will be out after this class. And from next week, we're going to have face-to-face lectures. And this is the last online live lecture of the first half of our class. And from next week, we're going to have face-to-face lecture. And after midterm, I'm going to do another survey and ask you which type of lecture you guys prefer the most, okay? And regarding the midterm schedule, it is not yet fixed, and I'm going to announce it once it's fixed. Any questions regarding course logistics?
글쎄, 레시테이션은 저번에 영상을 올랐던데, 레시테이션에 대해서는,
I didn't hear
음,
clearly. 좀만 크게 얘기해 줄래요? I guess it takes some time for you to ask your question. Just leave your question on the chat and I'll answer it after I solve these problems. Okay, this is where we left last time. I gave you 2 PPP exercises regarding linked list. And the first one was adding numbers. This question is about adding 2 numbers. And this is actually not 47, however, 74. And this one is 543. And you want to add these 2 numbers represented in linked list format. And I'm not going to just give you the answer or one solution. However, I'll just let you know how we can solve this problem. Okay, the logic is like this. Because we are retrieving the first element here and here, we can add these 2 numbers to get the last number, okay? So what we are going to do is we can loop through first LL and second LL. And what we are going to do is get one number from first LL. And we're going to get another number from second LL. And let's say this one is A and this one is B. And we're going to add these 2 numbers. And this is going to be the last result. And we're going to add these results in the result list. And we're going to append C like this. However, you need to be careful about one thing. If this number is like 5 and 8, then they're going to make a carry. If that happens, what we need to do is we need to pass that carry to the next iteration. Therefore, we're going to initialize carry as 0. And if carry occurs, then we're going to pass that carry to the next iteration. So what we actually need to get is not just A plus B plus D, A plus B, but we also need to add carry from the last iteration. That's the logic. And you know how to get carry and how to get D. You know percent operation. That is the basic logic of solving this problem. And think about it on your own after class. And I guess you can solve this problem, definitely. Okay, regarding the logic of this problem, do you have any questions? Okay, let's move on. And the second question was detecting whether a given linked list is circular or not. Here, I'm going to introduce one special technique called two-point technique. In the later of this course, you are going to see this technique quite a lot. And what we can do is, let's say we have a list looks like 2, 1, 4, 3, and 5. And we're going to keep track of 2 pointers. And we're going to call the first pointer slow and the second pointer fast. So this one is slow and this one is a fast one. What I mean by slow and fast is like this. This slow pointer moves just one node at a time. So let's say this at the first step, these pointers point to the same node. However, in the next iteration, this slow pointer, moves just one node, like this. However, the fast node moves 2 nodes. And if there is a loop, then at some point, these 2 nodes will point to the same node like this. However, if one of them ends, reach the end of the list, then that means there is no loop at all, no cycle, no circle. So what you're going to do is move these pointers until one of them reaches the end of the list. And before this happens, if these 2 points point at the same node, that means there is a circle. That is how you can solve this problem. Any questions regarding these 2 problems? Okay, let's move on. Today's main topic is stacks. And we know what stack is. Stack looks like this. We put a new item on the top like this. And when we're getting some items, then we can only access to the top item. We cannot access to the bottom items. It's like a stack of books. When you stack books, the bottom ones is the last one we can reach. We can only manipulate the top items like this. We can push new items on the top. We can retrieve items from the top. We cannot handle the items between bottom and top, these ones. If we want to reach the bottom item, we need to remove all the top items like this. And a stack stores a collection of elements. We've seen a lot of data structures for collecting elements, lists, arrays, and linked lists. And we're going to see more of them. And a stack behaves as a stack of books. When you stack books on the floor, it behaves as the stack data structure works. And you can only access to the top element. You can remove the top element or you can add new item on the top. That is the only position you can manipulate. And it works on the principle called last in, first out. sometimes abbreviated as LIFO. The last one is going to be on the top. And when you retrieve some item from that stack, that item on the top will be the first one that will be removed from that stack. And this is called LIFO, last in, first out. And stack ADT looks like this. We first need to be able to construct or make stacks, and that is supported by constructor. And we can push new items, pushes an element on the top, and it becomes the new top element. And this top function or method returns the element at the top of the stack. And pop returns the element at the top of the stack and removes it from the stack. The element just below, it becomes the new top element. And isEmpty returns true if there are no elements on the stack. And one thing to note here is when you are popping some items, you don't have to specify the index or the item you want to remove, because the only element you can access at this point is the top element. Therefore, you don't have to specify anything at this position. Therefore, this pop method does not accept any parameter. And top does not also receive any parameter because it only access to the top element and that is already assigned. So you don't have to specify any parameters for top or pop methods. And from now on, we're going to implement stacks. And by the way, stack itself is quite straightforward and easy to understand. Therefore, we will focus on the applications of stacks in this class. Okay, let's implement stacks together. There are several ways to implement stacks in Python, and we're going to see some of them. And before we do so, let's define some error classes. This empty stack error occurs when the stack is empty. Even when the stack is empty, and when we try to pop some items from the stack, then it cannot return any item because there is nothing inside this stack. If that is the case, then empty stack error occurs. And stack overflow is another common error that occurs for stacks. It happens when the stack is full and the user wants to push new item. If the capacity is already full, then we cannot put any more items on the stack. If that happens, stack overflow error occurs. And we're going to see how we can use them shortly. First, we're going to implement stacks using the Python list. Implementing stack is quite easy. We first need to define the constructor. And we're going to define the data using the Python list. And in fact, you can't just use this Python list as stack. And the next operation we need to implement is isEmpty. We're going to return if the self data contains no item, then that means this stack is empty. And we're going to implement push. We're going to append this item. This item goes to the end of the list we are keeping track of. In this figure, our stack is vertical. It's from top to bottom. However, in this configuration, our stack looks like horizontal. So let's say we have 5 items like this. Then this 1 is at the bottom, and this 5 is at the top. So you shouldn't be confused with this concept. In our implementation, it looks like horizontal, but in this figure, it looks like vertical, but both are okay. If you just rotate this vertical one, then we can get the horizontal one. And they are basically the same thing. So we are adding the new item at the end, like this. And when we want to retrieve the top item, we first need to check whether this stack is empty or not. If that is the case, you are going to raise empty stack error. If that is not the case, we're going to return the item at the end. Because the end position is the top position, we're going to return the last item in this list. So that is this top operation is doing. And we also need to implement the pop method. We also need to check whether this stack is empty or not. If this stack is empty, then we need to raise empty stack error. Otherwise, we're going to just return self-data.pop. And Python list also offers this pop operation. And this is basically the same as the stack operation. It's going to return the last element. Therefore, as I mentioned, you can just use this Python list as a stack. However, we're just implementing this interface. And we can implement another method that returns the size of this stack. We can just return the length or the number of items inside our list. Okay, this is the implementation of stack, and let's test our stack a little bit. After initialization, when we check if stack is empty or not, then it's gonna print out true. And after when we push some new item, after push, it's gonna print out false. And we can also push like new items like this. And we can also print the top item by calling the top operation. And we can also pop some items from this stack. And we can repeat this process several times. And the top item will change. Okay, let's check how it works. After initialization, the stack is empty. It's true. And after pushing, the stack is empty, returns false. And after we push 8 and 9, it says the top item is 9. And after popping, the top item gets out of this stack. And when we check the top item again, then it's now 8. Okay. So this is our test code for our stack we implemented. Okay. And I'm going to give you the first PPP exercise of today. Our first PPP exercise is minstack. And let's see what this minstack is doing. One thing you can note here is this minstack inherits object. However, you can just remove this part. Even though you don't specify the specific parent class, and basically this object class is the default parent object that every object has to inherit. However, if you don't put this, then Python will automatically put this one. Therefore, you can just skip this part. Okay, let's see what this min stack is doing. When you push some new items like -2, 0, and 3, and this one keeps track of the minimum value inside this stack. So when you call get min, then among these 3 items, it says -3 is the minimum item. And it works as just normal stack is doing. Like when you pop, the last item or the top item -3 will be popped. And when you try to check the top item, then 0 will become the new top. And when you check the minimum, then between -2 and 0, -2 is the minimum. Therefore, this operation returns -2. I'll give you the template of this min stack. It should have the constructor. It should have push. You should be able to push new items like this. And you should be able to check the top item. And you should be able to pop the top item. And you can also get the minimum value inside this stack. And one thing you need to be careful about implementing this get min is it should be O1 rather than ON. Okay? Think about it on your own, and before you solve this problem, please send me a PPP message. I'll give it one more minute. Okay, thank you for sharing your answers. Let's solve this problem together. I'll first describe how we can solve this problem. We will have just normal stack like this, or the data we want to keep track of. Let's just call this one stack here. If you just call this mean operation, then it's going to take O(n), because this mean operation is basically O(n) operation. Therefore, you cannot just use this default mean function offered by Python. What we can do is keeping track of two lists. The first one is stack, and the second one is min stack. And how it works is like this. When you push -2, then we're going to add minus to our normal stack and to the min stack as well, because this is the first line. This is going to be the minimum value. And at the next step, when we push 0, then what we are going to do is add 0 to this stack. However, we're going to compare this value to the current minimum value. If this value is larger than this one, we're not going to add 0 to this one. Therefore, min stack just stays the same. And in the next step, when we push -3, we're going to add -3 to this stack. However, this value is larger than -3. Therefore, we're going to add -3 here. And when we push 5, then we're going to append 5 here. However, this value is larger than -3. So we're not going to add 5 to this min stack. And as you can see here, this min stack means like this. After -3, -3, this one is the minimum value. And before we reach -2, like 0 and -2, -2 is the minimum value. So it's like this. Until we remove, so we're going to add new numbers like this. And let's say we have added another number, like 1, 2. Then until we reach -3, the minimum value is always -3. So we're going to just return -3 as our minimum value in the stack. And once we remove -3, then we're going to remove -3 from this min stack as well. Then the current minimum value is -2. And we're going to remove items one by one. And until we reach -2, this one is the minimum value. Okay, let's implement this one together. Here, we're going to keep track of two stack. The second one is min stack. So this one keeps track of minimum values. And when we push new item, we first append this item to our normal stack. And if this min stack is empty, or the last value is larger than or equal to the current item, then we're going to append this value to this min stack as well. So you can think about this condition. And the top operation is just same as the normal stack. We're going to return the last item. And pop, we first retrieve the item at the top from our normal stack. And if this temporal value equals to the minimum stack's last item, then we're going to pop this item from min stack as well. And we're going to return temp. And to get the minimum value, what we need to do is just return the last item from our min stack. That's how we can implement this min stack class. Any questions up to this point?
I have a question.
Yeah.
So in our first example, the first value we inputted was -2, which is kind of the second minimum value that's in the array, that's in the stack. What if we also input, like, as the first input we can do like 5, and also like after that we can input like -1. And if we can follow this logic, it will be like 5 and some other minimum value.
So your question is, what happens if we push items in this order, like 5, -1, and 3,
Mm-hmm.
and -2?
Yeah.
Yeah, let's check how it works. So when we first push 5, then our stack contains 5. And our min stack should contain 5. Because up to this point, the minimal value is 5. Can you understand this part?
Mm-hmm.
Okay, next, when we push -1, then our stack contains 5 and -1. And our min stack was originally containing 5. However, when you compare this -1 and the last value in this min stack, -1 is smaller. Then we need to add -1 here. Therefore, the stack now contains 5 and -1, and the minimum value at the moment is -1, the last value in this min stack. And after this, when we push 3, we're going to append this 3 at the end of stack, and we compare this 3 with the last value of min stack. And 3 is larger than -1, so we are not going to do anything to this min stack. Okay? Then we're going to push -2. And when we compare -2 with -1, -2 is smaller than -1. So we're going to add -2 here. So when we call get min, then we're going to return the last item in this min stack. And among 5, -1, 3, -2, -2 is the minimum value.
Mm-hmm.
Okay? And when we remove this one, we're going to compare this -2 with the last value in this min stack. If these two values are the same, we're going to remove this and this.
Mm-hmm.
And when we check the last item, among 5, -1, 3, -1 is the minimum value. And when we want to pop again, 3 will get removed like this. However, 3 is not equal to -1, so we'll just remove this item from stack, but not from min stack. And between 5 and -1, -1 is the minimum value. So can you understand how it works?
Yeah, I got it. Thanks.
Okay. Sungsu has another question on top and pop should work as just ordinary stack. Yeah, that is correct. You should not reorder the items inside stack. It works as just normal stack. However, we're just keeping track of the minimum value. So this is a new functionality. Other functions should work as just ordinary stack. Any other questions? Okay, let's move on. Up to this point, we have implemented stacks using the Python list. However, this is data structure course, not Python course. And sometimes you need to implement stacks using other languages like C++ or Java. In those languages, you cannot use Python list, and you should use arrays to implement stack. And that's why we are discussing how we can implement stacks using arrays. Yeah, let's first see how we can implement stack using arrays. In the case of arrays, we have fixed capacity. We can only store fixed number of items. And here, we're going to keep track of the position of top. And this is going to be called top of stack, TOS. At first, this one indicates, this one refers to nothing. However, once we add new item, then this top of stack will indicate the first one. And when we add another item like this, and TOS will go here. And after this, when we remove this one, then TOS will go back to the first position. So this is basically how we can implement stacks using arrays. We're just basically changing this top of position. Okay, let's first implement the constructor. In other languages, we first need to specify the capacity of the array. And we're going to simulate that behavior. Let's say our array contains capacity number of nonce like this. And at first, our top of stack is -1 outside of this array. And to implement isEmpty, we just need to return whether our TOS equals -1 or not. And when we want to add new item, what we are going to do is, first we need to check whether our stack is full or not. So we're going to add 1 to our TOS or TOS. And if this one equals the length of our stack, then we need to raise stack overflow. Stack overflow. If that is not the case, we're going to increment TOS 1. And then at the position, we're going to add new item like this. And have you guys heard of Stack Overflow? This one is a very famous developers community. When you go there, you can ask questions regarding programming or computer related things, and you can also answer other people's questions. And as you study computer science more and more, you're going to encounter Stack Overflow quite often. Even though there are many other communities, developers communities, this one is one of the most popular one. And you can ask questions regarding programming. And some of you might have encountered blue screen when you're using your computer. And sometimes the blue screen states that Stack Overflow error occurred. And it really is about stack. And I'm going to explain what this Stack Overflow regarding blue screen is about shortly. Anyway, when stack is full, we say Stack Overflow error occurred. And when we want to retrieve the top item, we first need to check whether this stack is empty or not. If that is the case, we are going to raise stack empty stack error. If that is not the case, we are going to return the item at the TOS position. And when we want to remove items from this stack, we first need to check whether this stack is empty or not. If stack is empty, then we cannot remove any items from the stack. And we're going to retrieve the item at the TOS position. And we need to decrement TOS by -1. And then we're going to return the item. So this is the implementation of stack using arrays. If you don't use Python, then this is the ordinary or the standard way of implementing stacks. We can check the operation of our stack implementation. Here we need to specify the capacity of stack. Then it works perfectly as before. So they behave in the same way. And when we think about the implementation, the behavior is just the same. However, the implementation is somewhat different. However, our users don't care about the implementation. They just use it. This is the abstraction or abstract data type. And sometimes you yourself need to implement your own data structure or your own stack or this min stack. And think about how you can implement min stack using arrays like this. Any questions up to this point? Okay, let's move on. Up to this point, we have used Python list and arrays to implement stacks. However, we can also use linked nodes or linked lists to implement stacks. I'm going to give you the definition of node. And we can use this node class to implement stacks. One of the, I'll first write this one. One of the disadvantages of this stack is that we need to specify the capacity, and we cannot dynamically change the length or the capacity or the size of this stack. That is not very useful, and it's very cumbersome to change the capacity. And in other languages where we cannot use Python lists, we can solve this problem by implementing stacks using linked nodes. So that's why we are discussing this topic. So we can implement stack using linked nodes. I'll just give you the template. Of this class. This is our next PPP exercise. Think about it on your own, how we can implement stack using linked nodes. As before, please send me a PPP message before you tackle this problem. And take some time and try to implement stack using linked nodes. Okay, I'll give you one more minute. Okay, let's solve this problem together. Thank you for sharing your answers. By the way, if you cannot solve this problem in time, don't worry too much because I'm not giving you enough time to solve these problems. I know it. But you just need to, if you can think about, oh, how I can solve this problem and some strategies to tackle these problems, then that's okay. And if you can solve these problems during class, then that's perfect. However, even though that is not your case, don't worry. If you can understand implementation and after class, you can think about on your own and implement these, then that's perfectly okay. All right. Let's implement this stack together. We first need to define TOS, top of stack. However, this one is first none because there is no item at all. And when we check is empty, we just need to check whether the TOS is none or not. Pretty easy. And when you want to push new items, you just need to update our TOS as a new node. And the current TOS becomes the new endpoint. And this one will become the new TOS. And the top item, you first need to check whether this one is empty or not. If this one is empty, then we're going to raise empty stack error. Otherwise, we're going to return the item of the toss like this. And when we pop from this stack, we also need to check whether this stack is empty or not. If this one is empty, we need to erase the empty stack error self is empty. Otherwise, we first retrieve the item from this current toss and then update the current toss as the toss of the next one. And we're going to return this item. So this is basically how we implement stack using linked nodes. Any questions regarding this implementation? Okay, Sugerel, is it right how I pronounce your name?
It's right.
Yeah, that is a good question. When we are adding nodes, so this one is related to linked lists. First, it was none. What toss is referencing. However, when we add new item, then this new item, so basically this is our first configuration. Toss is referencing to none. And when we add new item, then this item's next one is current task, right? The current task is none. So when we add new item, then this one's next item is going to be current task. This is what this expression is doing. And we're updating this new node as the current task. Now, this task goes to this way. And when we add another item, let's say item 2, then this item 2's next item is current task, this one. So item 2 is created, and because of this expression, the next item of item 2 becomes the current task. And this assignment updates the current task to this one. So this is how linked nodes are working. Do you understand how it works now?
Yeah, I got it.
Okay. Any other questions? Okay, let's move on. And there is another application of stacks. In our computer systems keep track of stack frames. What this stack frames is doing is each stack frame stores local variables of a function. And it gets created every time a function is called. And it gets destroyed when the function returns. And the start times and return times of functions form a nicely nested structure, just like the balanced parentheses. And it is like stack. What I mean by this is, and the Python interpreter keeps all stack frames on a stack. So every time you call a function, then the local variables of the function is stored in a separate stack frame. And Python runtime stack is limited to 1,000 stacks. Therefore, if you call more than 1,000 function calls, then it will just raise stack overflow error or memory error. This is what we saw. I'm not sure if you saw this in the last class, but anyway, let's look at this code example. Look at this main function. This one receives some input, text input from user. And if the user enters nothing, then this function returns. Otherwise, it prints beginning of try block and then changes the integer, the user inputs, and then call the function f. And what this function f does is printing starting of f and calls g. And before ending f, it goes to g like this. And then this g function divides 100 by this n user inputs, but it prints first, hey, the function g is starting, and then print out the result, and then ends the function. And after this g function gets started and terminates, it returns here. And then the function f terminates and then go back to this position, and the try block terminates. And as you can see here, the beginning of try block, starting of F, starting of G. And after this is the first item, second item, the third item. And it looks like stacks because the last one goes into the stack frame, gets terminated first. So this one gets terminated first, and then the function, and then the try block. So the first one goes into the stack, the try block, gets terminated at the last time. And this looks like stacks. And actually, this is what Python is doing and other computer systems are doing to keep track of the local variables of functions. Okay, so it's like checking parentheses. And what I mean by parentheses is like this. Let's say we have some parentheses like this, and this one is balanced. However, this one is not balanced. We know this because the opening one is not closed. And we know that for each opening one, we should have a corresponding closing one. So when we write mathematical operations, so we use parentheses like this. And this one is nicely formed because this one gets opened, this one opens, and this one is closed by this one. And the next one is closed by this one. And after all these elements are closed nicely, then this opening one gets closed. However, when you look at this one, this is not balanced because this opening one is not closed by this one, but this curly brace is not closed by this parenthesis. It's not possible. Okay, so this is not balanced, and this is balanced. And I guess you guys all know how to check whether a given set of parentheses are well balanced or not well balanced. However, we need to write a code to check whether this one is balanced or not. And how can you do that? And the strategy is like this. Strategy. We are going to first make an empty stack. And for each symbol, what I mean by symbol is this opening or closing parenthesis. If the symbol is an opening one, push it on the stack. If it is a closing one, then here we have three cases. If the stack is empty, then we return false. Because for each closing one, we need to have a corresponding opening one. If the top of the stack does not match the closing symbol, this one, then it is not balanced. We're going to return false. Otherwise, if the current top one matches the current closing one, then we're going to pop the stack. And after we do this for each symbol, we're going to return true if the stack is empty. After we inspect all the symbols. Otherwise, false. This is the strategy to check whether the given symbols are balanced or not. Let's implement this together. Okay, this one looks like this. So this balanced symbols receives strings and checks whether the given string is balanced or not. What we are going to do is we first make a stack. And for each character in this string, what we are going to do is, if this character is in this opening ones, then we're going to push this character to our stack. Otherwise, if this character is a closing one like this, if stack is empty or not matching, and I'm going to here implement this matching. For this opening one, I'm going to define this closing one. And for this parenthesis, I'm going to define this closing one. As a dictionary. And this will check whether the given one corresponds to this closing one. So this is the matching function. So it checks whether the given closing one matches the opening one, like this. And this happens, we return false. Otherwise, you are going to just pop from this stack. And we're going to ignore other cases because this could contain like this one or 2 + 3, like these expressions. So we need to ignore these parts. And after we loop through all the characters in this string, if stack is empty, that means everything is matched. And if stack contains some items, that means some items are not matched. Okay, so this is how we implement whether the given string is balanced or not. Okay, that's all for today. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.